welcome to another episode of Dynamo Next, Data Computational, Parametric Modeling. Last episode of the year, Season 2, Episode 7. I wish I would have gotten 12 of these done, but with the travel and everything, it's just been crazy. You know, having a baby this year, that's always good in the mix. So, Dynamo for MEP. We've got a special guest today, Sean Fruin with Sigma AEC Solutions. Sean is a graduate of the University of Missouri, St. Louis. He's a Bachelor's of Engineering, emphasis Mechanical Engineering. He's worked for KAI in both the Design Build Department in St. Louis, as well as their Dallas office, where he worked as a mechanical designer. He is now with Sigma AEC Solutions in Dallas, and he's also working on getting his PE. So please help me welcome Sean.
Hello, everybody.
Great.
Thank you.
Sean, go ahead and tell us a little bit more about yourself.
Yeah, so mechanical engineer, you know, I kind of had the drafting job on top of doing mechanical calculations when I started. So I kind of got lucky in that sense. Started using Revit. Did a little bit of CAD before, but mostly Revit. Found Dynamo and kind of changed my perspective and kind of where I'm going with life. Me and a couple buddies are now starting this new gig, Sigma AEC Solutions, where we kind of hope to disrupt the AC industry a little bit by applying all this wonderful knowledge that we're all sharing today. So,
perfect. All right, so let me get on to our next slide. So this one's for DLR Group. Just a reminder, before we get started, do not put any general time down. It's kind of a working lunch. We are a little bit earlier today than usual. We usually like to be on the mountain time zone so everybody can have a staggered lunch, but I do want to provide the staff with more opportunities to learn amidst project deadlines. So have this open on your third monitor or your second monitor and just kind of follow along as you're kind of working on other things. So just real quick, kind of a year in review, season 2 in review. We've had a lot of amazing content. We've had a lot of tutorials out there, learning sessions. So feel free to go to the YouTube channel, check it out. We've had all of our amazing guests, and it's all been recorded this year. So I'll send a link out later for that. This has been fairly successful. We've almost had 100,000 minutes of watch time and about almost 30,000 views across the world. So this is taken off a little bit more than I first had anticipated. Let's talk about what we're going to learn about today, though. So this is really more about learning about Dynamo and the things that Sean's been able to do. We might run a couple scripts, we might not. Some of them take a little while to load, so we might just walk through them instead. Because we want to learn about how Dynamo can be used for mechanical engineering, but we're also going to maybe think of some spin-offs of that too. Sean's going to show how he created some workflows that shorten tedious modeling and kind of data entry efforts, and really develop a sense for how to organize your scripts. So really, without further ado, I'm going to stop the screen share and hand it over to Sean. All right, it's all yours.
all right, so this is kind of the end product. We're going to kind of work backwards. Like I said, putting all this geometry, all these mechanical equipment, all these diffusers was done via Dynamo scripts rules. So, okay, so here's the job we're doing. Everyone knows this model, I think. It's the wonderful model that comes with Revit. So again, all these diffusers and everything was placed via Dynamo script. You can see the nice patterns and everything on rules. We placed all of our VAV boxes right here throughout the model, and even those thermostats have been placed right here for the respective VAV boxes. So this is kind of where we're going. Now I'm going to go back to the beginning and show you how we got there. So I've worked in doing a lot of government healthcare facilities, and we did all of our air balance stuff in Excel. We've tried to do it in Revit, but it was pretty complicated. And again, because entering data into Revit is kind of tedious, it took a lot of time. So we had these Excel workflows, and I wanted to know how to, put them into Revit. So what we built out here is the first script right here reads out our linked model and takes the data that we need for our air balance table and pushes it into Excel to fill out our air balance table. So we already have our spaces in there. And the first thing we want to do is just kind of sort the spaces to give them in order. I hope everyone knows it doesn't come into Dynamo numerically. It's how it's in order of they were built. So just making sure they're in order is the first step, and then pulling out the stuff that we need. So we want the number, the name, the area, ceiling height, volume, the amount of people in the room.
Fantastic.
And then the really important thing is the room code.
Yep. And is that a custom parameter inside of Revit that we would have to make?
Yeah, so my kind of way of doing it, the ones that are uppercase, lowercase are native to Revit. That's just how they come in. And then when I've made a, pardon me?
Oh, you're good.
And then when I've made a custom parameter, I've always made them all capital. So as you can see, ceiling height is all capital, and architecture, occupancy, and room code is all capital. We get this location because that's how we're gonna place equipment later. And then, so we put that all back into a list. So for the zones, this is how we get our mechanical equipment. So we have a standard on zoning our buildings. So it's air handler unit dash the VAV box. So like 01-01 would be air handling unit 1, VAV box 1. So we want to get that unique list of all the zones. So the zoning we did in Revit through the wonderful tools that they have for, where is it, analyze.
Yep, so after you place some spaces, you zone them out, and that's all data.
That's all data, so we're gonna use that data. So we're gonna pull the HVAC zones back in. So let's go back to our Excel now. And again, rather than run the script, I kind of cheated and did a copy paste. So let me just paste this in. And then as you can see, all this data filled out. So if we go back here, again, these are those parameters that we pulled in from Revit. And then with these parameters, we're able to fill out all of our other stuff. So pretty powerful stuff. Sorry, my computer's running a little slow.
That's all right. This happens.
Yeah. So let's just keep on going. I just think it's cool how much data comes in and how much is filled out. So you can see all this is blank, but if we put that data in, all these formulas fill out to get the respective data.
You know, what's going through my head also is we could be using this for architectural reasons. I mean, you've got it so beautifully organized. We could have things like square footage, work to area ratios, furniture plan ratio, all kinds of information that we can pull straight from Revit if we build the model and kind of customize it a little bit.
Right, correct. Another really cool thing about Excel is the dashboards. So I've seen people do it, and there's other programs to do it too. If you can pull that data out, you can get a really cool dashboard that a client would probably like to see rather than, you know, a database just full of information that's hard to tell what's going on. So that's another cool aspect. So another thing to bring up kind of here, so it all fills out. You can see inputs come in. So this one's an air transfer. So that takes care of our balancing the building. This one, I'm working on a script to do this, but right now, you know, manually go in, see where this is transferring. But the cool thing about Excel too is you can filter this stuff down. So let's say I just wanted to see the ones that needed an input. You could do that.
Okay, so it's all tabled out too. So you've got this, you've got this thing all tabled. Very nice.
Mm-hmm. So then from the zones, and this is where it gets kind of important. So these zones came in from Excel and we labeled them appropriately. So now we just break that data back up. So if it's exhaust, now we have our exhaust fan. You know, our air handling unit is just the zone number, but you can see our return fan. You can overwrite this if you want. Our air handler number is there. So what's cool about that is now you come into here and then this starts filling out. So again, if I ran the script again, then these numbers would come in, and then here you have all these formulas up here to sum up. It looks pretty long, but it automatically fills out like your air your other schedules. So this link is being built between the spaces and all your other schedules.
Fantastic.
Yeah, so let's get out here. And the cool thing is, so that's the first step, right? So we brought all this information in, we did a little bit. Again, we'd put our loads in there, was a column in there and everything. Then the other thing you do is now this thing is built to go both ways. So after the stuff's filled out in Excel, you can hit run, and then it'll populate all your schedules in Revit automatically and update them automatically. So if you make a change in the air balance table in Excel, then your Revit will update. If you change zoning in Revit, your Excel will update, which in turn will edit and update the other schedules in Revit.
Accurately. Accurate.
Too. Yeah, that was the main thing to go. You know, we all get in the rush, I think, and changes are happening. The architects, you know, the architects changed this on us, or the engineers are behind, and this last minute thing happens. So it really eliminates having to change stuff in multiple schedules, and therefore eliminating the amount of errors you can have by manually input, working in a rush, stuff like that.
Right. So that's kind of why our engineers kind of wait to the last second to do these things sometimes, because the architects are always changing, even through CDs. And,
right.
And
so you can see, like, yeah, so the very beginning inputs that feeds all the way through is those inputs like area. So if, you know, here, if an architect changes an area, then, you know, the CFM is going to change for that, location. So now we don't have to, it'll change automatically. So that's pretty cool.
And it's really nice, because then I don't want to say it's less communication, because I'm not necessarily the best communicator. We all need to work on that, but I'm not going to necessarily email you every time I move a wall in a lobby. But this will kind of catch that. So.
And the other thing too, so it decreases our lead time quite a bit. So rather than needing the model a month out, you know, maybe we need the model 2 weeks out. And obviously shortening that time as much as we can, you know, I think is better for both sides. So
I think I'm understanding a little bit more about why you made this.
It was
pretty epic.
Yeah, I was definitely in the trenches for a few jobs, and, you know, just a lot of pressure to get stuff done quickly, a lot of data. So if you're talking about,
oops.
Hello?
There we go. Sorry, we're good. Sometimes we lose the call in this office. We're good.
Yeah, so it's a hard question to answer, is how much time is this going to save? And up front, I mean, I remember at point we did the calculation of like how many clicks and stuff it'd be and how many variables. So when I was doing this stuff manually, I think we had 24 variables that we had to put from Excel to Revit manually, times however many rooms you have. So it gets up there. Now that I've got this scripting stuff done, I'm actually pushing in a lot more variables than I did before. I think I'm almost up to 100 variables. And now those variables are being used to drive other parametric design stuff, and that's what we'll get into next.
Cool.
So to finish this.
I was going to say, I see you have everything called out and organized by color. Did you do that for your benefit, or in case someone else needed to use it?
Kind of both. And I think definitely if you're going to implement this across a firm, you know, bigger the firm, the more complex it gets, having a good standard color scheme would, you know, benefit everybody. So like green, I always do green for Excel typically.
Yep.
This one, because I was pulling data from Revit, I made it blue. Usually when I'm setting parameters, I go gray. Usually when I'm sorting, I do a different color. And then again, we're setting parameters.
Okay, interesting.
So here, I'll focus on the room. So these ones up here too are kind of doing the same thing. So we took all this data from Excel, and now we are setting all this data. So this happens to be, you know, our air handling unit data to be set. So now we can have a schedule in Excel and have the same schedule in Revit and quickly just update it. So then same goes down here for spaces. So now that we got all this data, oops. So now we're pulling all the data from Excel and pushing it back into Revit with all those calculations. So here, like, just to point out a couple things, it's pretty straightforward. And by the way, I started using code blocks kind of probably a year into my Dynamo journey. Because if you do set by parameter name, you get these, it just starts to get really messy. So
yeah, that code starts to get really, really long. You got a lot of spaghetti strings going into it is the problem.
right.
So I like
It's
what
really
you've
hard
done
to
here.
move stuff.
Very clean.
So, and another thing about, if we're talking about the color and standards and everything, it's a really good idea. And maybe this, like right here, I put conversion. So that lets me, like, why did I do this? Like, for example, I haven't really looked at this script for over 6 weeks. So, you know, I might come to this and someone's asking me a question like, why did I do that? Well, it's because there's conversion here. So putting these notes in there also helps a lot. Keep it straight for the end user and also the designer. I think it benefits. So stuff I'm learning. I was never a computer science major or anything. So kind of learned this stuff the hard way.
So here's a good question. What would you say to people out there who want to learn this, but are maybe too intimidated by what they see right now?
Don't go, so scripts get really complex. Don't even try to understand those first. Try to like see what they're doing and get the big picture, but don't try to copy them. A lot of people, since I've been publishing this stuff, has asked for like scripts, like, can you give me this script? And I'm kind of hesitant to do it, not because I don't want to share the knowledge, but it's because it's probably not going to work for them. We all know how finicky these things are and how they can break. Unless you have built the script up, you're probably not going to be able to diagnose the problems. Plus, you know, all those parameters that I had to build myself have to be in there. So it kind of has to be a process. So I would get good ideas from all the, I mean, it's an awesome community. We all know that. So I would look for inspiration and ideas to see what you can do. But as far as learning it, I would kind of start off small. I remember the first thing I learned was, and I thought it was the coolest thing ever. I was geeking out about it. And I think people thought it was crazy because it wasn't a big deal. And it was just taking an Excel list of room names and updating it to Revit. Like, I thought it was the coolest thing when I first figured it out. So like start that, like get a simple, okay, here's what I want to do. How can I do it? Don't think you're going to be able to write a script, you know, this kind of this big or complicated right off the bat. And at the same token, once you're kind of over that learning curve, this stuff really isn't that complicated. There's a lot of patterns involved in it. If you see, like, we're doing the same thing here that we're doing here, that we're doing here.
It's just a copy up, right, copy down.
It's just a copy, so don't get intimidated by that either. And, you know, you're just going to have to put in, it's learning something. So, you know, it's kind of like learning a different language or learning a different math class or something. Practice, 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 and just get in there and trial and error. And I think the best way you're going to learn is by doing it. There's a lot of little things. I want to make at some point a thing like things I wish I knew starting Dynamo. I think would be very helpful because there's a little bit of coding stuff in there too. Like right here, we got a string to numbers. Like that will give you an error. You know, if you're new, you're not gonna be like, why is this error? This doesn't make sense. So getting kind of around the nodes and pointing those out would help.
Yeah, I think the Dynamo primer on the Dynamo website is also really, really handy. It's great to search that and find out what string to number really means and when you have to use that to convert number values to string values because of the different inputs. So I think it's just a learning process. Yeah,
definitely. Like I said, and kind of another thing, write out what you're doing, your flow on paper. Like, get the big picture, get your end goal, and then work backwards, I would say, is kind of how you want to approach. I think that's a coding kind of lesson that, you know, that's taught also, so.
That's what I tell people too, is start with a goal in mind and work backwards from it, because all your parameters are going to be based on that goal. And usually that goal is a performance metric of some sort, right? You want certain transparency of a shading device. And so you've got a range, you want to set up a range and you want to set up a depth and a thickness. Well, those are all parameters, and those are all, you know, toggle controls, if you will. And so if you can work backwards from what you're trying to achieve, this program is custom built to achieve goals. That's really what it is. It's also great prototyping software. I mean, you've literally basically coded a piece of software.
I like to tell people, you know, and we all kind of have this issue with trying to explain and sell Dynamo to other people. And, you know, like your description of Dynamo is not going to be the same as my description of Dynamo. And anytime I pitch Dynamo, I find myself at the end of the conversation, sometimes it's a different thing than I had the same conversation with somebody else and they get something else out of it. A good way that I like to look at Dynamo is any add-in almost. I really haven't found one you can't mimic with Dynamo. And then like you said, with the custom ability, it opens up just a lot of options. So
yeah,
I think what's really cool about it.
Getting back to,
I'm not a coder, and yet I've done things where, you know, you're building pretty much add-ins, which I never, 2 years ago, I've never dreamed of doing. Like, that was crazy to me.
Yeah,
so
that's right. So getting
that,
back to kind of why you wrote this script too, if you could go back into the Revit model and just re-emphasize. I know we had a couple people join a little bit late, but that script essentially, get back to it, placed all that information for you accurately.
So that was the big thing. If we go here, where are all my schedules? So there's all these schedules that all are linked up. And like I said, the reason I did this is because we had to update all these schedules. You know, you're doing something 3 times in a row.
Yep.
And it's a lot of data. So if you can build these links, it's like you'd have to input CFM here, right? And then I'd have to sum up.
Manually.
Right, manually is the craziest thing. And if it's hard to, I think, unless you're in the trenches with, right, it's not like Excel. I can't put 250 here and then drag this down, right? So I have to put 250, right. I have to click, I have to put 250, enter. And now I'm like looking at my other spreadsheet over. I only have one pointer. I'm looking at my other spreadsheet over here. So like, I don't know, I get kind of spacey when I was doing this, right? So I have 2 monitors. I'm trying to keep track of the one over in Excel, you know, to go down the list. And it just, I watched it. I couldn't, there'd always be, you know, some little error in it. And it would just spend a lot more time fixing it. So yeah.
What I like about this.
Time, go on.
Oh yeah, no, what I like about this is, again, now thinking about it in terms of maybe architecture, interior design, there's what's stopping me from doing this with furniture, right? Even if it's block form, right? Because you're placing families that are VAV boxes, probably some sort of Titus air terminal, something to that effect. Well, it's no different conceptually than a couple of pieces of furniture, table, conference room table, and just letting that place it out manually. Just say, pick center of the room. I mean, at least get it in there. Because otherwise we're doing that manually.
Right, all that stuff. And yeah, I'll show you that script. Again, to your point with the furniture, you can see this nice pattern here. Like this one turned out great. They're not all great. Like this one, and you can write more rules.
Sure.
Here, let's just jump into that script right now. I think we've kind of
let's take a look at that.
Pushed the point of, you know, that we can feed information back and forth from Excel, start linking up equipment and stuff. So yeah, let's go.
I mean, we're talking about collapsing the process dramatically.
Right, and it's not just the time up front. That's another thing that I really want to hit on. It's not just the time up front. It's able to have the building adapt to changes. So
yeah,
and then you can even go as far. So let's go to this. So this is pretty cool. So everything's built out. So these numbers are going to change if I update my Excel sheet, right? So let's say the big one I like to do is if you change the % outside air, everything's going to change, right? So let's blow this diffuser up to 350. And you'll see that the neck size and everything changes. So our neck size jumped up. Our tag here for our schedule changed. So this is built all the way through. So you don't have to worry now about, you know, editing all the diffusers. Because literally, if we change something dramatic like that, Now someone has to go through, re-enter this number, right? Re-change the size of this diffuser, you know? So it's, you know, you get this model that just can adapt to changes. It's really cool. And then, I mean, the future going on from this part, once you have control over it, is now you could probably start optimizing and doing stuff like that. So that's why I emphasize more than the upfront time. It's the control that you have after, and the time again that you're saving when changes happen.
It almost wouldn't be outlandish to say a 9-month CD design time schedule for all disciplines could go from 9 months for a 100,000 square foot building. I'm kind of making up numbers to, I don't want to be too outlandish, so I'll say something from 9 months down to a month.
Yeah, I mean, I'm totally with you.
Yeah,
I don't see it, like, for me too, I don't know that much about architecture, but like zoning, I don't see why you couldn't write an algorithm to necessarily zone your building. You know, it's based on area, the load,
math.
So I think, and obviously there's never going to be an out of the box solution. So it is worth your time to learn this stuff, because I don't think it's ever, Autodesk, I don't think it's ever going to be able to like hand you, you know, here's the script that's going to build your building for you, just because there are so many variables. And also, you know, are you in education? Are you in healthcare?
Absolutely, yeah.
In California? Are you in New York? Are you in the Midwest? So, but if you have a lot of jobs in your firm that you do over and over and over, kind of like I had the healthcare government jobs, well, once you write these rules for that type of job, you have it. So, you know, first year, it might take you, let's say it is going to take you more time to do the job, the first job. But by the second, third, fourth, fifth job, and if you are fixing these as you go, like, you know, improving them, you know, that lead time gets shorter until, I don't know, I hope in my career that we're to the point where you almost can hit a button and watch a lot of it go. And then, you know, it's the PE's job to still look at the drawings and check everything, but you know your math's going to be right because it's built in there. You know that your zoning is going to be right because you made up the rules. And maybe it is a little bit hard to get the one glove fits all, but pretty close right off the bat.
Yeah, and that gives you, think about the time that you have now to look at it, and you get to do your job instead of finagling with numbers and sliding furniture around and trying to move all these things around in the model and trying to keep it all coordinated. You've got a ton more time now to,
correct.
You know.
Yeah. So, and also you get more accurate results. So these would obviously have to go into the ceiling tile, but, you know, for a diffuser, there's a certain throw radius that you have. And
sure, again, controlled by ceiling height too. So you've got that volume data input.
Right, and then you can even, you know, put in your manufacturer, whether it's price or whatever, I don't know, whatever manufacturer is, you can put in that engineering data to get that length for the separation for the diffusers. And so now you're left with, you know, the ideal location, not just a location because it looked good or because it seems right. You know, you built in those parameters already. So again, sorry about my computer running a little slow.
That's all right. So while that's going, I think we're right at about the 30-minute mark. I could open this up to the audience. What other processes would benefit from this? I could see lighting calcs being done this way and applied to the fixtures. I could see serial and model numbers applied to specific furniture. I mean, what's everybody thinking?
I mean,
it looks like you could also use this maybe to build a model of the walls to input. You could export that to a Excel file to do load counts.
Yeah, I have looked at that. I have gone down that road. Something I've learned with Dynamo, and I'd love anyone's input on this. I was kind of determined to figure out load calcs with using Dynamo. And the thing that I've learned though, you know, we build these really complex models in Revit. And this is kind of why I think the export with GBXML doesn't work. you build these really complex models. Like if you have a window and the framing goes in a little bit, that's going to come out as a whole separate wall. So to manage all that, like if it's a square rectangle room, like works wonderful. Yes, you can do it. You can do it really well. You can even use vectors and stuff to get the orientation of the wall, and you can use Dynamo to find out if it's exterior wall. Like I said, the issue that I do find is that you have the geometry is just so complex for, it's really hard to manage it, if that makes sense.
Yeah, and we're not talking about replacing train trace or anything like that. We're just asking Revit to do a little more.
Right, and I do have to give kudos. So I was working really hard on that, and now I've stopped because I do have to give kudos to Autodesk actually for Insight 360. So if you're looking to get, I think they have gone through the process of figuring that out. So far, I've gotten pretty good results for them. At some point, I want to do kind of a case study and compare it directly to train trace. I did at one point, I was 98% accurate, and with loads, I mean, that's a fairly good number, especially loads, because I think if you ask 3 different engineers to do loads and train trace, you're gonna get, hopefully they're close, but you're gonna get 3 different total values back just by how you pull out the geometry.
Okay. Well, I think Brandon's got a question.
Yeah, I mean, I just wanted to touch on the point you guys brought up earlier. I think part of one of our goals is to see how we can begin to start integrating scripts that are able to be used normally on most projects. And I think, I mean, just looking at your script, your building geometry is relatively rectilinear. It seems like a lot of the spaces are relatively straightforward in this example, but I'm just wondering if we wanted to take your script, for example, and apply it to a project that had a more complex geometry. Are the variables that need to be evaluated still able to easily be identified? I think I'm just trying to reiterate that as part of the challenge of getting this as a selling point to a lot of people within the company.
So something that I think we struggle with and that I pushed is to pull this stuff off, you definitely need standards. So like if you're making your own parameters, you need standards. So again, it's hard to take someone else's script. And this is why, again, I don't think you're ever going to get the just out of the box thing that does all the stuff that Revit can do. You have to build it up yourself because, you got to follow your own rules, per se. But once that's done, it's done. And that actually question leads into this script pretty well. If I'll run through this really quick.
Sure. Walk us through this.
Yeah, so this is the script that places the diffusers. So like you're saying, with the rectangle rooms, it's pretty simple to place the diffusers, right? Mm-hmm. The rules are pretty easy. Like for this one, the rules were pretty easy to set these. And again, there's not a complicated really room here. But what you do is, so here we pull in our spaces. We get some architectural data. So that's pulling in the doors and stuff. So we have that location. That's how all the diffusers, by the way, are. So I pulled in the door point right here. And that's how I was able to put this. So I said, okay, give me the room. I have that center point because I got the space, right? I said, what doors does it have? One of these, it has 2 doors. So this one has 2 doors, and that's because there's so much CFM in these diffusers, we need to put 2 in. So that's built into the script. And then it's just, okay, here's the door. Give me the wall that it's on. And what's cool about this is you start getting into, kind of 3D calculus and vector stuff. So give me the wall that it's on. So now I have this vector. Okay, make a normal to it. Now I have this line and this line. And now, okay, which point is closer to the center point? This point. So that's where we're going to put the diffuser. And sorry, another thing that I didn't point out was not only are we putting the CFM and everything, we're also putting in the room number right here, the space number, and the zone that it's on. And this lets us grab all these quickly and filter them, because pretty much a lot of what you do in Dynamo is just filtering. So
Yeah, you're managing lists.
Right. So that leads me in here. See, this whole spot right here is filter space by system type. So not a big one right there. So just does it equal, yeah, does it equal SA? So then we do it here. But then I think here's more filtering. And now we're using those parameters that I just put in. So give me the space number, does it equal this? And then here's the part that I was going to get to about complex geometry. And so we asked questions based on the perimeters, and then we broke it up into sets of rules.
This is awesome.
Yeah, so here's the rules. So rule 1, is it a stair? Because we didn't, there's no ceilings in stairs, there's no anything else in stairs. So that was a rule 1. Is it a stair? If it's a stair, do something else, right? If our space is under 100 square feet, well, now if we try to make that grid in the space, it's going to be out. We're not going to even get a point in there. So this one says if it's under 100 square feet, then just put the diffuser in the center. And as you see, these come over here. It's kind of hard to see all of it together. I'm sure it's confusing still to you guys. But yeah, so it's just a location point. So just put the supply diffuser at the location point if it's under.
Okay, fair enough.
So here we have, okay, so here's another rule for if it's a corridor. So if it's a corridor, we're gonna get the bounding box and we're gonna find those extreme, and then we're gonna take a vector into the room. So now we kind of have it at the endpoints. And then if not, we're gonna make that grid. Now we're gonna make the grid in the room and put them that way. So does that help your question? So if you have more complex rooms, it would just take a different rule to take care of that problem.
Yep, that makes sense. Now, let me ask you this. What if a ceiling isn't in that room? And
so that's a great question. And this was kind of built for, so again, remember at the very beginning, one of those ones was ceiling height. If we go way back here to the very beginning to the Excel, one of those parameters was ceiling height. And of course it didn't pull in for some reason, but that's something, if that parameter is filled out and we have slab to slab, well, now we can ask ourselves, is there a plenum? No, there's not a plenum. Okay, then do this rule, right? There's no drop ceiling. Right. So now we have to put it in the wall. So that would just be another set of rules that you would filter here, so you could literally go, no ceiling rule, right?
Nicely.
Yeah.
So it'd be space, does, and
yep.
I don't know, it's probably not gonna work because I'm working fast, but it'd be something like space. I don't know. I know this isn't the right.
Oh, that's fine.
Yeah, just equal slab to slab for that floor. So again, it does get kind of complex, but it can be done. It's just asking yourself, equal slab to slab, and then filter that out.
Yep.
Does that make sense?
Makes sense, yeah.
Yeah, you just basically haven't come across any other rules that you've needed to set up in your specific instance, but I really like the way that you set this up. I mean, it's laid out like you
yeah. So of course that broke it because I wasn't doing the right
yeah,
thing.
That's another thing about Dynamo is there's a lot of pain involved sometimes.
Yeah, and that's something that is I will admit that's kind of this is why standards are so important. Keeping scripts in multiple places in case someone gets in there and messes something up. I'm sure we all know about it, but eliminating a lot of these issues, I think, as Dynamo player, which I just got my hands finally on. So now you can, so no one else at the firm except the power users even have to look at the scripts, right?
Right. So we'd have our volunteers from our BIM management that want to tackle this, and then any people that want to tackle kind of that computational expertise, and really make a hard-hitting development team, if you will, so that the non-power users can use Dynamo Player that just click a button and do that crazy thing I asked you to do. Awesome.
Right.
And then we got all these like, you know, Dynamo programmer users, power users that are just cranking these things out and have built a lot of very, very unique knowledge
So
with this.
here's something that's kind of cool, again, to the Dynamo user stuff. So like a lot of people aren't really good, don't really know Revit, right? And so one of the things we do is we go to a draftsman. We're like, hey, can you put, let's just use hood. Can you put a hood in room 306, right? So it's either an email or a note or something, or just a conversation. And, you know, it just takes time for even that information to get from person point A to point B, and then the person has to put that into their schedule, and it just starts dragging out that lead time, right? About how much time it takes to get stuff done, right? Because the drafter already has, who knows how many things in their plate. So something else that you could do here is, so I had this thing. So someone could put in, you know, a mechanical engineer that doesn't know anything about Revit can put, okay, I need, and there's even if statements built in here. Like this one came up automatically. So you can even put if, like this one, see, this was a dental lab, and there's actually an if statement that put that mechanical piece of equipment there, or you can manually override it and select them yourself. So what we did was took all the Revit families, categorized them. So if I want a kitchen hood or whatever, and then when I hit run, that Dynamo or the place mechanical equipment script, this piece of equipment will get placed in the center of that room.
Nice.
And then again, just like the diffusers, you could write rules to put it in the ideal location. Like if you already have an exhaust duct penetrating the ceiling, well, you can get that point. So put the hood right underneath that, or like a radiator panel. If you have a window, just like we did the return diffuser with the door, then okay, put it, you know, a vector this way away from the window. So it's pretty cool, you know, just eliminating just a lot of communication errors and all that.
Fantastic. Well, I think we have time for maybe one more question. Whoever gets to it first, we'll open up for questions. If not, I want to thank Sean for joining us today. Any questions? 3, 2, 1. All right. I want to thank Sean for joining us today. I'll upload this video over Christmas break. I'll send a link to Sean's videos on his channel. They go through the rest of his scripts. Just a fantastic resource. And Merry Christmas, everyone, and have a Happy New Year. And
of course, feel free to, you know, I'm kind of passionate and geeking out about all this stuff. So feel free to email me or ask me any questions. Watch the videos. They're obviously longer. So feel free to, you know, come at me with any questions you got.
Fantastic. Well, that's it, everyone. Thanks for joining.
All right, thanks a lot.
Yeah, good.
Thanks, guys.
Thanks, Sean. Thanks, Ryan.
Yeah, thanks, Sean.
Cool.
No problem.
Thank you.